So in previous video we have learned about the operational concepts, theory behind how the different operations is being performed inside the computer, what all components are there, how are they being connected, those things we have learned. Now with the help of example, how those things can be related, we are going to check. So as I have said, we are having one example like load, add and store. So this is just a sample. This is not the correct form of representation. So just for sample, we are taking this example. Load opcode, so numeric value, it is used here 1, add it is considered to be as 5, store is considered to be as 2, and the operand part it is given like 940, that is one address, 941 another one, 941 that is the addresses that is being given in the operand field. So inside the memory we have learned that it will be having the instruction as well as the data inside the memory. So here you can see that load 940, it is stored in the memory like 1940. Okay, 1940, and second instruction add 941, it is stored as 5941. Why? Add value that is assumed to be as 5. The next instruction store 941, it is given like 2941 inside the memory because the numeric value assigned for the store is 2. Okay, so these things it is stored inside the memory with their corresponding addresses like 300, 301, 302, like that it goes on. Now in the operand part it is given as 940, 941 and 941, which means that you are referring to two memory locations 940 and 941. It will be having the actual values that need to be processed by the processor, that is 3 and 2. So in order to perform this operation, that is you need to perform the addition of these two values and store the result in 941. Okay, അപ്പം 941 you need to store the value, that is the final result. Okay, then so in order to start the execution, PC will be having the that is the first instruction address will be placed in PC. So first instruction it is placed in 300, so that will be placed in PC, and AC currently nothing will be there. And what is the first thing that will be done? You need to fetch the instruction, that is the load instruction will be fetched from the memory. So for that an initiation will be given like read from the memory. So the MAR will be having this 300, which is copied from the PC. Control unit initiates the control to the memory, reads the value, and it will be placed in, first it will be placed in MDR. Okay, MDR. And then it will be copied to the instruction register. Okay, then what it does, that is a fetch cycle. First instruction it is being fetched. Now it decodes the instruction. So when it decodes the instruction, it understands that the operation to be performed is one, that is load. Okay, load, which means you need to load some value that is the given in the operand field, that is 940. 940 means it is a memory location. So some value is written in 940, loaded in 940, that is 3, which need to be loaded to the accumulator register. Okay, so what happens? So this address 940 it will be placed in, again it will be placed in the MAR. 940 will be placed in MAR. What it does, from the MAR, value will be, that is from the memory, value will be taken. That is from 940. What is the value? 0003. It will be placed where? It will be placed in MDR. Okay, so from MDR, the value will be given to the AC. Okay, that is the accumulator. So what is the value? 3. It will be stored in accumulator. Now see here, the PC value will be pointing to the next instruction address. So next instruction is add, which is stored in the memory location 301. Okay, so PC is automatically, it gets incremented and will be pointing to the next instruction. Again the same process. From the PC address will be copied to MAR. From MAR, control unit, it initiates the read control signal. So what happens, from 301, the next instruction, that is 5941, will be placed in MDR. That happens in step 3 here. Okay, and from MDR, the second instruction from MDR, it will be placed to the instruction register, that is 5941. Okay, again during the execution phase, what happens? PC automatically gets incremented, or PC gets incremented pointing to the next instruction, and instruction register, what in decoding will be done, like what is the operation to be performed and what is the operand that need to be taken. 5, that is operation to be performed as addition. Operand will be taken from the address 941. From the address 941. So here 941 will be having 2, that will be fetched in the MDR, and will again it will be copied to AC, that is 0. AC will be currently having that is add 941. Okay, currently AC is having 3. Okay, and data that is being fetched is 2. So add 941 means this 3 will be added with the MDR value. Okay, from memory the data is being placed in the MDR, and to that MDR value the current AC value will be added, and the result where it need to be stored, again it need to be stored in the memory location, but before that the updated result after addition, it will be stored in the AC, that is accumulator. Okay, after addition the result will be stored in accumulator, that is 5. And again what happens, next instruction, PC is pointing to the next instruction 30, fetch the next instruction, that is store 941, which means that there is one address that is currently in MAR, that is the current last address. What was that? 941. To that 941 you will be loading the result value. Okay, before that you need to fetch the instruction from the memory 302. So 302 is having 2941. So that 2941 will be placed in MDR, and from that MDR it will be moved to IR. So here it is 2941. Okay, no, you know, here next step அடுத்து it is in the next slide. Okay, like here that is step 5. You can make it as step 5 like 5941. 5941. So from this it decodes the information. So not 5929. Hoping that you are able to understand. 2941, that is PC is pointing to the next instruction to be executed, that is 2941. 2941 means 2 indicates store. So 2941 will be placed in IR, decodes the instruction, and it understands that we need to processor needs to perform the store operation to which memory location? 941. So to 941 it need to store the result. So this 002 will be overwritten as 0005. Okay, so this is the process that is being done. Apart from these operations like a transfer of data between memory and processor, or transfer of data between IO device and memory, or IO device and processor, there is one another form of data transfer, or in command transfer, like in the form of interrupts. So normal program execution can be interrupted when there requires any urgent servicing. That is, in between any urgent operation need to be performed by the system, or some input is required by the user, means there occurs an interrupt. It can be a hardware interrupt or a software interrupt. The details, some more detailed information regarding this interrupt will be handled in the upcoming modules. For time being, you just understand that apart from this data transfer, that is transfer of information in the form of instructions or data, there is one another form of signal also can be transferred between these components, that is called as the interrupt. Okay. So to deal with the situation immediately, the normal execution of the current program must be interrupted. So interrupt is a request from an IO device for service by the processor. So this interrupt will be raised by an IO device in order to be handled by the processor. So for that, some sequence of operation will be performed, like the device will be raising an interrupt signal, and processor, it provides the service by executing an interrupt service routine, which means that while you are executing some program, when you are executing some program, in between the program there is a need for some file from the system. So what happens, current program is being terminated, and processor, it takes the file from either from the IO any other device, or from the user. The name of the file can be obtained from the user, so that the file can be fetched. So what is the task to be done based on that request? That task will be called as the interrupt service routine. Okay, some operation that is being performed when an interrupt signal is being raised, that is given in this interrupt service routine. And during that process, the current state of the processor will be saved, so that after performing that task, the processor can return back and resume its operation. So that is called as the interrupt service routine. It is similar to that of that subroutine execution. What is the task being performed in subroutine execution? when a subroutine is being called, it executes that subroutine and returns back to the main program. Similar is the case here. When interrupt is being raised, it executes that interrupt service routine and returns back to the